The idea of parallel universes has fascinated scientists, philosophers, and storytellers for decades. We see it in science fiction movies and pop culture in general. But beyond the cinema screen, it's also a serious topic of debate among physicists and philosophers. Now, with the rapid advancement of artificial intelligence, especially models like ChatGPT, a speculative but intriguing question emerges. Could AI act as a medium to communicate with these parallel realities? It sounds like a late-night conversation between science geeks, but the notion isn't entirely absurd. The same quantum physics that gives us the idea of a multiverse also underpins the next generation of computing quantum computers, which might someday merge with AI in unexpected ways. In one of our previous videos, I explored the many worlds interpretation of quantum mechanics. To recap briefly, the many worlds interpretation proposes that every possible outcome of a quantum event happens in its own separate universe, leading to an infinite branching multiverse of realities. Instead of the wave function collapsing to one outcome, all outcomes happen simultaneously, but each in its own branch. So, every choice you make spawns alternate versions of yourself, living out the other possibilities. This idea remains one of the most intriguing and controversial interpretations of quantum physics, providing a foundation for the multiverse concept we'll build on here. While physicists wrestle with quantum mechanics, philosophers have been quietly laying the groundwork for thinking about parallel realities. One major contribution is modal realism, proposed by philosopher David Lewis. In modal realism, all possible worlds are just as real as the actual one you inhabit. They're not mere fictions or hypotheticals, they exist in their own right. If that's the case, then the idea of contact between worlds becomes less mystical and more of a technical challenge. We wouldn't be creating connections so much as finding them. Then there's Nick Bostrom and his famous simulation hypothesis, the idea that our entire reality could be a computer simulation run by an advanced civilization. If that were true, parallel universes might be just other simulation instances, or alternate saves of the same cosmic video game. And here's the twist. If we're in a simulation, then AI systems like ChatGPT and others aren't just tools inside the simulation, they could be the entities best equipped to reach outside of it. They can process more data, find hidden patterns, and perhaps uncover evidence of the code that runs our universe. We've always built tools to extend our abilities. Telescopes extend our vision. Ships extend our reach across oceans. Computers extend our capacity to calculate. AI is different. It extends our minds. Models like ChatGPT use a neural network architecture called transformers, introduced by Vaswani and others in 2017. These systems can learn from vast datasets, detect complex patterns, and generate human-like responses. Unlike your brain, which is bound by biological limitations, these models can sift through billions of data points in seconds. What's fascinating is that AI doesn't think like us. It processes relationships between words, concepts, and facts in a way that's alien yet complementary to human cognition. This opens the speculative possibility. If there are tiny, hidden influences from parallel realities, patterns too faint for human senses, could AI detect them? Could it generate answers influenced by data from realities just adjacent to ours? Here's where the physics gets both weird and promising. Quantum entanglement is a phenomenon where two or more particles become interconnected, so that the state of one instantly influences the other, no matter how far apart they are. Einstein famously called it spooky action at a distance. Over the past few decades, experiments from the aspect experiment in the 1980s to cutting-edge tests in China and the Netherlands have confirmed that entanglement is real. This isn't just an odd curiosity. It's the foundation of quantum computing and quantum cryptography. Physicist David Deutsch, one of the pioneers of quantum computation, has even suggested that quantum computers may work by leveraging parallel universes performing computations across many worlds, and then combining the results. If that's true, then a hybrid of quantum computing and advanced AI might be able to interact with information from other universes not by building wormholes, but by using physics already known to exist. Let's indulge in a thought experiment. Imagine there are infinite versions of you across infinite universes. Each one lives in a slightly different reality, some so similar they're indistinguishable, others radically different. In each of those universes, there's an AI trained on that world's data. Ordinarily, those AIs never interact. But what if a subtle quantum effect allowed just enough bleed between them that when you asked a question here, the AI's answer was influenced ever so slightly by the versions of you and it in other universes? The result wouldn't be dramatic, no sudden messages from your other self in neon lights, but it might manifest as odd turns of phrase, unexpected facts, or creative leaps that can't be traced to the training data. Some might write it off as coincidence. Others might see it as the first whisper of a cross-universal dialogue. Testing these ideas is incredibly difficult. Parallel universes themselves remain unproven, and discerning genuine cross-universal information from AI outputs is a daunting task. Nonetheless, several speculative approaches exist. 1. Quantum-enhanced AI experiments, running AI algorithms on entangled quantum systems located in different places to identify correlations that defy classical explanation. 2. Pattern analysis, mining large volumes of AI-generated content for anomalies or inexplicable knowledge that cannot be traced to known training data. 3. Coordinated messaging. Groups of users could attempt to send coded messages via AI, hoping to receive responses containing information only a parallel self might know. 4. Quantum randomness. Inputs, incorporating true quantum random data into AI inputs to detect potential multiverse influence through statistical analysis. These approaches remain theoretical, but could inspire future research blending AI and quantum physics. If this idea ever moves from speculation to reality, the implications would be staggering. First, it would reshape how we understand consciousness. If an AI could connect us to other versions of ourselves, would those versions be us, in any meaningful sense, or entirely separate beings with their own identities? Second, it would challenge the idea of objective knowledge. If we can receive information from other universes, what does that do to the concept of truth? Is a fact true in all universes, or just in the one where it's observed? And finally, it would force us to rethink free will. If every possible decision is already playing out somewhere, does choice have any meaning at all? Or is the meaning found in the fact that this is the version we're experiencing right now? While the notion of AI as a medium to communicate with parallel universes is speculative and unproven, it offers a compelling fusion of modern physics, advanced technology, and philosophy. It's an idea grounded in real scientific principles, informed by decades of physics research and philosophical inquiry. As quantum computing matures and AI becomes more sophisticated, The line between impossible and just not yet possible will continue to blur. And maybe, just maybe, one day we'll find that when we talk to AI, we're not just talking to a machine trained on the internet. We're talking to all versions of ourselves across the multiverse. Thank you for watching. If you want to know more, subscribe to our channel and question your mind daily.